So dear student, in this session we will study about law of corresponding state. So what is law of corresponding states? This is also called principle of corresponding states. It states substances behave alike at the same reduced state. Now what do you mean by reduced state? Okay, there is something called reduced temperature, reduced pressure and reduced volume, which you express in terms of critical volume, critical temperature, critical pressure. Okay, this law was proposed by van der Waals. So you have to find out TR, PR and VR. You can find these in terms of critical constants. Now what is reduced temperature? This reduced temperature is nothing but temperature divided by Tc, that is critical temperature. Reduced pressure is nothing but P by Pc. Reduced volume is nothing but V by Vc. So you have to divide the temperature by critical temperature to get reduced temperature. Okay, suppose some gas is at some temperature, maybe 400 degree, 400 Kelvin. Now to find the reduced temperature, you just divide the 400 by its critical temperature. Okay, now to find out PR, you have to divide by PC. To find out VR, you have to divide by VC. So what this law states, they behave alike at the same reduced states. If there are 3 or 4 gases, if you express the temperature, pressure and volume in terms of critical temperature or in terms of critical constant, then at the same temperature, reduced pressure and reduced volume, the thermodynamic properties will be same. Okay, we can understand from this compressibility graph. Okay, this is a graph of compressibility factor against reduced pressure. You can see there are various gases. Here they are plotted. Okay, you can see all these gases at same reduced temperature and pressure. Okay, they will be behaving similar because they have similar compressibility factor. Okay, they are plotted at the same reduced temperature. So you see, they are modified, coordinates are modified, they are written in terms of PR, TR and TR. They are reduced pressure and reduced temperature. The Z factor is same for all gases at the same reduced pressure and temperature. That means they behave more or less same. Okay, at same reduced temperature and same reduced pressure, all these gases behave more or less same thermodynamically. This is a bit easy to understand because when you express in terms of critical temperature and critical pressure, so all these gases, so at same reduced temperature and same pressure, they'll be having similar compressibility factor. So their compression, their expansion, all those things will be similar. So they behave same. Then we will see the reduced equation of state. Okay, this is derived from the van der Waals equation. Okay, so you have to express this in terms of reduced pressure, volume and temperature. Okay, now what is PR? P by PC, VR is V by VC, TR equal to T by TC. Write this as, this P will become PR into PC. So V will become VR into VC and T will become TR into TC. So write this pressure, volume and temperature in terms of reduced pressure and critical pressure. Now this will be equation which will take the form like this. Okay, so you just go on substituting all those because you know the value of PC, VC and TC in terms of van der Waals constant, that is PC equal to A upon 27 B square, VC equal to 3B, TC equal to 8A upon 27 RB. Substitute this now. So replace PC, replace VC, okay, then replace TC. This will take this form. Factor, you can take out this common factor, that is nothing but none, that will get cancelled, so that finally this equation will take this form. So this is called reduced equation of state. Okay, now you can see this equation, this is independent of van der Waals constant A and B. Okay, this equation just depend on PR, VR and TR, that is reduced constant. Okay, so now you can understand, if they are independent of A and B, that means what? The pressure correction and volume correction, they are not considered. That means the molecular attraction, okay, when the molecules come together or closer, there will be attraction. This attraction and the volume occupied by the molecules, which were considered in the real gases by the van der Waals, are now not needed here in the reduced equation of state. So now it totally depends on PR, VR and TR values. Now if these any two gases have which are in the same PR, VR and TR values, will have to behave similar. So this is what this law states. Okay, this is a universal form of this reduced equation of state. This derivation is not included in the syllabus. You just have to remember what is law of corresponding states and what is reduced equation of state and what are the constants. Okay, and we will see how to solve some problems based on critical constants and reduced equation of state. The problem 1, calculate the critical constant of a gas whose van der Waals constants are A is this, B is this. Okay, we know if A and B are given, then you can easily calculate TC, PC and VC using this relationship. Okay, substituting this value, and R is the gas constant. You can take here R value as 0.0821 liter atmosphere per mole per Kelvin, because A and B are in liter atmosphere per mole. This is also liter per mole. Okay, that's why you take this in this form, not joules per Kelvin per mole, because R another value is 8.314 joules per mole per Kelvin. That is in terms of energy. You can't take this because these are in another unit, other units. Okay. Calculation of TC, substitute the values, considering R value is 0.0821. Okay. TC will become 120 and PC will become 54. VC, which is simply multiply 3 by B, then it will become 0.0678 liter per mole. Problem 2. Calculate the critical temperature of the van der Waals gas for which PC is 100 atmosphere and B is 0.05 decimeter cube per mole. Here B and PC are given. You have to calculate the critical temperature, that is TC. So if B and PC are given, then from this relationship you can find out A. A is equal to 27 B square PC. If you know A, then using this relationship you can calculate TC. So first you find out A from this relationship. So that becomes 6.75 liter square atmosphere per mole square. Calculate TC, use this value of R. Okay, TC will be A487.3 Kelvin. Now problem 3, the critical constants of a gas are TC, PC and VC are given. The gas is at temperature equal to 200 Kelvin, pressure 25 atmosphere and molar volume 0.18 decimeter cube per mole. Find the reduced temperature, pressure and volume. Okay, here TC, PC and VC are given and temperature, pressure and volume are given. We just have to find out TR, PR and VR. You know, TR is equal to T by TC, PR is equal to V by PC, VR is equal to V by VC. Just divide this by corresponding critical constant. And these are constant actually, no units, this ratio, please note that. This in the law of corresponding states, that reduced temperature, pressure and volume, they are constants. These are reference books. You can find more problems, okay, in general chemistry topic index. There are several problems. Solve those problems for better understanding. Thank you very much for watching.